All right, so hopefully you've already done the warm-up. We've talked about that many times. If not, pause it right now and do it right now. Okay, so identifying what we're looking at, this is point-slope form. So that means we have a point and a slope. So the point is the opposite of x and the opposite of y over and over again, and the slope is right there. So we plot that point, 1, -8, and the slope is -1/4. So that's down 1 to the right 4, or up 1 to the left 4. And I'm going to make sure we're getting those in the right place. Okay. So when we connect these points, we want to use the ones the furthest two apart, because that'll help us get it in the right place. And then don't use the point itself. Look at the lines underneath. Look at the lattice point where they cross each other. Don't get distracted by the dot you made, because the dot might not be in the best place. And it's really important to get that line in the right place. So now let's go to the next one. And that one is here. And that one is in slope-intercept form. So the intercept that they're talking about is the y-intercept. So when x equals 0, y equals 2. And you can see that when you plug 0 in there, y equals 2. And then here the slope is 3. So 0, 2 is right there. And the slope is 3. Now I could keep going up that way, but I have another line down here, so I figure it probably needs to come down here and down 3 to the left 1. And sure enough, it passes through. And these lines have to intersect perfectly. So if they don't intersect perfectly, then one of them is wrong for our class, because we're doing this on purpose for them to cross to make a certain shape. Lines don't have to cross perfectly at lattice points always, but in our examples they will. And so if they don't, you know you made a mistake. So I probably don't need to go all the way across there, so I'm just going to stop. It's possible. It's probably not that. It's probably not going all the way across there. Okay, so there's 2. Now, the next one, we have another point-slope form. So that's going to be the opposite of that, and the opposite of that. And there's our slope of 3. Now, at this point, hopefully, some of us are like, hold on a second. Those two are the same. So that means those two sides are parallel. Okay, so just something to keep in mind as we continue here. So -2, 9 is up here, and the slope is 3. This is going to be a ways across here to get down to that other line. And sure enough, it passes through also perfectly right there. So there we go. There's our third line, and we have one more line to graph. That one's in standard form. So standard form is when we plug in 0 for x, and then we divide by 8, so we get 2 for y. And we plug in 0 for y, and divide by 2, and we get 8 for x. So we plot those 2 points. 0, 2 is right there, and 8, 0 is over here. And when I'm in standard form, I like to think about what the slope is. So this is going down 2 over 8. So the change in y is 2, and the change in x is 8, and it's going down from left to right, so it's negative. So that slope is -1/4, which we should say, hey, hold on a second, those are parallel also. So this is going to go left 4 up 1, left 4 up 1, left 4 up 1. It goes through perfectly right there. I'm going to do one more, but we already can hopefully see our shape right there. So now, if we had to graph something else on here, I might want to erase part of this line or something, but they need to have arrowheads on them because we're graphing those lines. So don't, I think I mentioned this before, I've had some kids erase all of these and just have the shape. We don't want to go that far. Okay, so area. So this one is a little bit tricky. So how are we going to find the area of that? There's a couple main ways we could do it. One is to kind of see if we can get some right triangles going. So if I look at that corner and I drop this straight down, and then I drop this straight across, I get a nice triangle right there. Okay? And if I come over here and I draw this straight down and straight across for the red one, I guess I could have done that in red. Okay? Bit higher there, but oh well. So that's good. I got these nice two triangles here. I'm going to color code these to match the lines that they're with somewhat. So this one's going to be purple. And I don't have a red highlighter, but I have pink, so that's going to be over here. So we can find the area of those two triangles. That would be good. Up here, if we draw that straight across, we get a little sliver of a triangle up there, which could be green. That gets a little tricky because that's so narrow down there. And then also down here on the bottom, I can look at this blue triangle because that line was blue. Okay, so that, now we hopefully realize we can find all those different areas. Now, to me, the easiest way to do that is if I look at the blue and the green triangle, that's 1 by 4. I know it's hard to tell, it gets pretty narrow down here, but it's 1 by 4. And if I were to take those two triangles and put them together, maybe I'll do that over here. So here is the blue triangle. Let's see if I can color this in nicely. And then I'm going to put the green triangle. So imagine, now you could just find the area of those triangles and add them all up. So it's 1/2 base times height. And you could do that. I'm going to pause this for a second. All right. So what we could have done was we could have found the area of this triangle, multiplied it by 2 because those are the same side, find the area of this triangle, multiply it by 2 because those are the same side, then add this little rectangle up in the middle. That's one way to do it. Another way to do it is to take these two little triangles and put them together. They're 1 by 4, and the area of that little rectangle is 4. So I'm going to have 4 plus, and now if I take these two triangles and I put them next to each other, you can see that that's 3. And this is 1, 2, 3, 4, 5, 6, 7, 8. 3 by 8. So this is 3, and this is 8. So the area of those two triangles together is like a rectangle, so that's 24 because they're right triangles. And then we just counted, that's 8. That's 8 by 1, a rectangle. So that's 8. So that is going to be, let's see. All right, small miscalculation there. That's actually 9. Miscounted. That's 9. So 9 times 3 would be 27. So that's 12 plus 27. That's 39 units squared. Okay? So some students get a little confused when you're trying to draw those lines. They need to be perfectly meeting. So before we go on the perimeter, let's just do the classify the quadrilateral. So we noticed, hopefully, that these two slopes were equal and these two slopes were equal. So that means it's at least a parallelogram. Now, when you look at that, you might be wondering, is that a rectangle? But that's not a right angle. That's an obtuse angle. So remember, to be a right angle, the slopes have to be opposite reciprocals. So this would have to be 4, or that would have to be negative 1/3. These would both have to be negative 1/3, or these would both have to be 4 to get opposite reciprocals. So it's not a rectangle, so that means it's a parallelogram. Opposite sides are parallel. Okay? Now find the perimeter. Okay, so this shouldn't be too bad because opposite sides of a parallelogram are congruent. So if we do the blue side down here, that's 1 and 4. So doing the Pythagorean theorem, we have 1 squared. It's going to be 1 and 16, so that's 17. So that's just root 17. So this side down here is root 17, and that side up there is also going to be root 17. Now this one was 3 and 9, so that's going to be 3 squared. Maybe I should switch colors. So the red side here, the purple side, is going to be 3 squared plus 9 squared. I'm going to call that d squared. I don't want to use c again. If I did want to use c again, I could call this, put a little 1 under here, and then put c, and then put a little 2 down here. But I don't want to have too many numbers there and get a little too confusing. So that's 9 and 81. That's 90. So now when we take the square root of both sides, hopefully we all see that's 9 times 10, or 3 root 10. So this side is 3 root 10, and this side is going to be 3 root 10. And this side up here is also going to be root 17. So we're pretty much done with that perimeter now. We can say that the perimeter is going to be 2 root 17 plus, and 2 of these would be 6 root 10, and don't forget the units. Alright, so that's our warm-up question. There's a lot of stuff going on there. That's why we like those questions. You got the question about the parallelogram, you got graphing lines, you have finding the Pythagorean theorem to find sides, finding areas. So there's a lot of good stuff in that question. Okay, let's move on to today's lesson. So today's lesson we are talking about some special types of parallelograms. And if we're making a family tree here, really the big category would be quadrilaterals, four-sided figures, quadrilaterals. And underneath the quadrilaterals we have parallelograms. And we have some other things too we'll learn about later. But so the big family would be quadrilaterals, just like we have in nature we have dogs. Dogs a big category, and underneath dogs there's lots of other categories. So there's poodles, but under poodles there's different types of poodles as well. So the big category is quadrilaterals, underneath there is parallelograms. Now parallelograms, there are rhombuses and there are rectangles. Okay, and then they have a really special one, which is actually a special type of rectangle and rhombus, and that's called a square. So it's kind of like a family tree here. Now, if you're going up the family tree, you are always. So if it's something above, it's always that. So a square is always a rhombus, a square is always a parallelogram, a square is always a quadrilateral. So if it's above you, it's always. Okay? If it's below you, then it's sometimes. When is a rectangle a square? Sometimes. When the four sides are equal, then the rectangle is a square. A lot of people don't realize that. Squares are a type of rectangle. Now obviously we're going to call a square because that's more information. That's more specific. But it is also a type of rectangle. Okay, so a Venn diagram. Let's just make a Venn diagram for parallelograms. Okay, so a Venn diagram, a lot of times they just use circles, but I got to fit a circle in there very well. Well, let's just do the whole thing. So the whole thing would be quadrilaterals, four-sided figures. Now within quadrilaterals, there would be this group that would be parallelograms. Some quadrilaterals are parallelograms, the ones in this circle. Now inside the parallelogram, we have rhombuses and rectangles. But before I draw those, I need to think about something. And the thing I need to think about is that the rhombuses and the rectangles overlap with the squares. I probably should have let you think about that, try it out yourself, because you did have the family tree. So I probably should have said pause and draw your Venn diagram. Sorry about that. Okay, so over here, I'm going to have the rhombus, and then here, and either or, whatever. So rhombus, hard time squeezing these in here, rectangle, and then in here, square. Might have been easier to draw little pictures for this. Okay, so that is our Venn diagram so far. Always, sometimes, never. Think about it. All right, so a parallelogram is a rhombus if and only if its diagonals are perpendicular. So let's take a closer look at that. So a rhombus, 4 equal sides. Let's see. I can't see those lines very well. Just trying to get that in the middle there. I think I did a very good job. My eyes aren't as good as they used to be. Okay, so I guess I could have drawn my diagonals in a different color. So there's my rhombus. That one diagonal, I guess I should draw the other diagonal. Okay, so there's our rhombus. Could have paused. I should have paused and drawn that, but if and only if its diagonals are perpendicular. So if you have a rhombus, the diagonals are going to be perpendicular. And the diagonals are going to bisect the opposite angles. So over here, that's showing that those two are equal. And that's showing those two are equal. And these, all 4 of these are equal. Actually, all 4 of those are equal. So that's what that shows us. Now, we have a rectangle if and only if the diagonals are congruent. So the two diagonals need to be the same length. I don't really want to draw, I could draw a rectangle there, I suppose. The diagonals are going to be congruent. All right, I'll do it. All right, so in a rectangle, the diagonals are congruent. I think to make that a rectangle, maybe I should have said these. There's a right angle here. A couple right angles. Just like up here for this rhombus, I probably should have marked these sides, 4 sides equal. All right, so the diagonals of a parallelogram bisect each other, and in a rectangle, the diagonals are congruent. So if they bisect and they're congruent, that means all 4 of those are congruent. Okay, and remember, biconditional means either way. So if you know the diagonals are congruent, then you know you have a rectangle. If you have a rectangle, then you know the diagonals are congruent. Same for those things up there. Okay? All right. That's a... All right. So, quadrilateral is a rhombus if and only if it has 4 congruent sides. Okay, that's what makes it a rhombus. A quadrilateral is a rectangle if and only if it has 4 right angles. So that's something that students get a little mixed up on. They think that the definition of a rectangle is the opposite sides are equal, but that doesn't make it a rectangle. That makes it a parallelogram. These, right, if it goes like this, those 2 sides can be equal, and these 2 sides can be equal. That doesn't mean it has to be a rectangle. What makes it a rectangle are 4 right angles. So that's the key there. Square has to be a rectangle and a rhombus. Okay, so let's check out a couple questions here. Decide whether the statement should be always, sometimes, or never. So a rectangle is a square. Now some kids, be careful. Okay, so if you don't know what I'm talking about, then you probably should wait to answer. So a rectangle is a square. A lot of people are going to say never, but that's not true. The answer is sometimes, if the 4 sides are equal. All squares are rectangles. Okay? And actually over here too, a square is a rhombus. When is a square a rhombus? What makes something a rhombus? 4 equal sides. What's a square have? 4 equal sides. So when is a square a rhombus? Always. 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 Okay. Let's move on to the next thing. QRST is a square. What else do you know about it? Okay. So we could say a lot about it. We could say it's a polygon. We could say it's a quadrilateral. Okay, we could say that it's convex, not concave. To be a square, it has to be convex. We could say it has 4 right angles. We could say it has 4 congruent sides. We could say that the opposite sides are parallel, and we could say a bunch of stuff about diagonals. We could say that they bisect each other. We could say, because it's a rhombus, that they're perpendicular. Because it's a rectangle, we could say they're congruent. And we could say that the diagonals bisect the opposite angles. I probably went a little fast there. You could have paused it. Anytime that you think, pause it for a second, see if you can do something. Okay, so like this example, I'm actually going to pause this and I'm going to draw a picture, because we told you that drawing a picture helps a lot of times. And I'm actually going to draw a grid for this as well. So I'm going to pause and do both of those things. You could do that also. Alright, so it says that we have EFGH is a rectangle, and K is the midpoint of FH. So let's try to figure something out here. So E, now you got to go in order, either way, but I'm going to go this way. So EFGH. When you name something, you have to stay in that order. They're going in order there. K is the midpoint of FH. Okay, so FH is a diagonal, and K is the midpoint of that. They also talk about the distance from E to G, so that's going to involve this over here. And actually, the good thing about drawing this is that it'll show me that that's going to show me where K is. So K is right there. EG is the whole thing. That's 8z minus 16. And now it's asking us what are some of these other things. So let's see here. So it's a rectangle, so we know that these bisect each other. Okay. So EG is the whole way across. EK is half. So EK is going to be half of that, which is 8z minus 16. So hopefully we can all take half of that pretty quickly. That's going to be 4z minus 8. Okay. Then it also asks for HK. HK is right here. The diagonals bisect each other because it's a parallelogram, and they're congruent because it's a rectangle. So if they cut each other in half and they're equal, then that means these are equal also. That's why I have those marks on there. So HK is the same length as EK. So HK is also going to be 4z minus 8. Okay? That was EK. EK equals that. Okay. Write a coordinate proof. So the first thing when you see coordinate proof is you should be using a graph. There should be coordinates. Okay? Now, it's telling us we have a rhombus. So I'm going to draw a rhombus on there. So rhombus has 4 equal sides. The diagonals bisect and are perpendicular. So we talked about plotting stuff on the coordinate plane before, and we want to do that so that we get as many zeros as possible, because if we have to make calculations, stuff with zeros in them is easier to calculate. So by making all of these the way I did, all 4 of these sides will be congruent. Okay, it's a rhombus. Now I'm going to start up here. I'm going to call this A, B, C, D, and I'm going to call this 0A. So the x coordinate at that point is 0, and the y coordinate is going to be A. So let's come down here and think about what would the coordinates of C be. Use that pause button. All the rest of the time we're doing video notes. Use the pause button and think. Use your own brain. Okay, don't just copy what we're writing down. That's not really too much thinking. I mean, you might think about it a little bit, but if you're making yourself write the coordinates of this point down here, you're thinking more. So hopefully everybody knows that the x coordinate would still be 0, And the y-coordinate should be the opposite of A, negative A. And over here, I'm going to call this B0. So if you come over here and think about what the coordinates of this would be, that would be negative B0. Okay, so if we have diagonals perpendicular, we're going to need, if you think about a graph and you're talking about perpendicular, we're talking about opposite reciprocals or vertical, horizontal. Vertical and horizontal are perpendicular also. So, if we look at the slope of AC first, the slope of segment AC, we're going to have the change in y. So that would be A minus A over 0 minus 0, which would be 2A over 0. Okay? Now, if we have something divided by 0, is that okay? No, it's not okay to divide something by 0. So that is undefined, which means it's vertical. Okay, which we can kind of see that from the picture anyway, but if we find the slope of BD, segment BD, that's going to be 0 minus 0 over B minus negative B. So that's going to be 0 over 2B, which is 0. Is that fine? 0 divided by a number. I'm using x for a variable to represent a number. Okay, yeah, it is. It's 0. And that is horizontal. 0 slope means horizontal. So we do have vertical and horizontal are going to be perpendicular of each other. So that just proves that that's going to be perpendicular. Okay. You cut out a parallelogram, so you know it's a parallelogram already, and you measure the diagonals to be congruent. So you have the parallelogram, opposite sides are congruent, and then you measure the diagonals, and the diagonals are congruent. So what shape does that have to be? That has to be a rectangle. Okay? An angle formed by one of the diagonals is 90 degrees. What? Then it's asking us, is the shape a square? So if we have 90-degree diagonals, what does that mean? That means that the diagonals are perpendicular. What does that mean? If diagonals are perpendicular, that means you have a rhombus. Okay, well, if you have a rhombus and a rectangle, that means you have a square, so yes. Alright, it's about that time. Have a good day, get on that assignment, get that turned in right away, don't wait.